Hi, I'm Tim Paterek. You're watching the video on lugged frame construction, and this video is going to be completely about hand crafting a bicycle. I will use as few machines as I possibly can in making this video, and also I will have two different frames going together at the same time. The two frames are quite different from each other, and I'll try to show you different options that you can use while you're making your frames. Okay, first of all, let's take a look at the printout, and right after that we'll take a look at the drawing. First of all, the printout, which is generated by the Paterek computer program, gives you a complete geometrical printout, it gives you a components printout, and it also does receipts for you. It's also a record keeper. This computer program is available from United Bicycle Tool Supply at a very inexpensive price. Basically, they're selling it for pretty much the cost of reproducing the program. You'll use this program, this printout, this geometrical printout, to do your drawing. So let's take a quick look at this drawing. This drawing is an old drawing. You can see by all the smudges and everything on it that it's been used. But we took an old drawing and we highlighted the lines with a magic marker so that the TV camera will pick them up. And basically, you can use the first chapter in the Paterek manual to do your drawing, or you can use the Paterek plotter program to have this done on an HP emulating plotter. First of all, you have to draw two parallel lines. This one right here is your bottom bracket line. Then you have to draw your axle line. This is the bottom bracket drop. Next step will be to draw in your seat tube angle right up through here, and your seat tube length, which will bring you up to here. Most frames will have an 1.1 inch seat tube. Some of the oversized frames, mountain bikes and tandems, might have an 1.25 inch or even 1.3 inch. Then you draw in your top tube. Always draw your top tube center line in level. If you want to go with an uphill top tube later, or a downhill top tube, as the case may be, you can draw that in later. But when you make the drawing in the initial stages, always make this horizontal to the ground. Put in your top tube length, then drop down at your head tube angle, and from there go forward your fork rake and drop down to the axle line. Then strike an arc with a beam compass up here for the tire diameter, and then work your way up the front of the head tube. First your tire clearance, then your fork crown thickness, then your lower stack height, then go to the back of the head tube and put in your intercept. Then at that point you can lay a ruler along that an 1.1 inch wide ruler. Lay the bottom of your ruler on the intercept, lay the center of your ruler down here on the center point of the bottom bracket shell, and then just pencil in that down tube, and hopefully you can find something that's an 1.1 inch wide that'll make it easy to draw that. That's your drawing. Keep your drawing simple. Don't spend a lot of time on your drawing, because as you can see from this drawing, they get torn and smudged and charred, and by the time you're done, it's ready to trash. Okay, let's take a look at our components. As I said earlier, we're building two fairly different bicycles here. One is going to be a full tour bike with long chain stays and a relaxed head tube angle, large clearances for fatter tires. The other one's going to be a racing bike. It'll be built with oversized tubing and oversized lugs, and it's also going to have stainless steel lugs and fork crown. So the two bikes are going to be quite radically different from each other, and I'll try to show you as I'm going along the differences that we'll see. Let's take a look at these tube sets right now. First of all, this tube set right here is a True Temper, just a basic regular weight tube set, and 14mm chain seat stays, continental oval fork blades, 1.25 inch head tube, 1 inch steerer. The chain stays are going to have to be dimpled. There are no flattened areas in the chain stays, so we're going to have to do our own dimpling. Down tube, seat tube are 1.1 and top tube is 1 inch. This is a standard road bike. We're using a Henry James bottom bracket shell with integrated under the bottom bracket shell guides. We're using Henry James lugs. This is a 72-degree head for touring. And we're using a set of Shimano vertical dropouts. There. And a set of dropouts, front dropouts to go with them. Over here, this is quite a bit different tube set. This one is a Prestige oversized tube set. We have an 1.25 inch down tube, 1.1 inch top tube, 1.1 inch seat tube. We have regular Continental oval fork blades, but we have oversized oval chainstays. 1 inch steering column, 1.25 inch head tube, and with this one we're using 16mm stays. So this bike is all oversized. This is being built for a heavier individual. Again, we're using a Henry James bottom bracket shell. This one is made for the oversized oval chainstays. Also the oversized down tube coming in there. This one's going to be a fancy bike. The seat lug is regular chromoly steel, but the two head lugs are made out of stainless steel. Those are going to be shined up and they'll look just like chrome. The fork crown is a standard Henry James fork crown. However, this one is made out of stainless steel, so we're going to be doing a lot of shining up on that one. That one will take about 3 to 4 hours of work that'll be all done off camera, and we'll show you the finished product. The dropouts we're using are G.P. Wilson vertical dropouts. These are made out of a 17-4 stainless, extremely stiff and pretty tricky to work with. So we'll go over the procedures on those. One other dropout that I want to cover is the Henry James dropouts. These dropouts, very attractive looking dropouts. These are made out of stainless. Where the other two sets of dropouts have tabs on them, these have plugs, and so we're going to be seeing exactly how these plugs work and how they get brazed together. So I'll show you those as we're working on the two frames. Alright, that about does it for the components. Next thing we're going to be doing is setting up the frames on the stone table. Let's take a look at the bikes on the stone surface table. Right now we have them laid out on top of the drawing on a set of V blocks on a stone table. This particular table is made out of black granite. It's one of the best, it is the best surface that you could possibly work on. A good runner-up is cast iron with a machine surface. Another good runner-up would be steel with a Blanchard ground surface. Do not use aluminum or stainless steel surfaces. They tend to distort quite a bit in an environment where heat changes quite a bit. Also, take a look at these V blocks. These are just standard V blocks. They go for about $25 a pair. They come in matched pairs, and I've got 2 of them, 4 of them, and these are exactly the same size because these are 1.1 inch tubes. Then I've got this one that's specially shaved down for an 1.25 inch tube, and between these 5 blocks they suspend this frame directly above the table, all the same distance from the table. If we go over here and take a look at this frame, this is the oversized frame. This one throws a few curves at us. This is an 1.25 inch head, or 1.25 inch down tube, 1.25 inch head tube, and an 1.1 inch seat tube. So because of that, I have to take the shaved block and build it up a little bit. I use just a shim of plastic. Back here I take this other set of blocks and I build those up also so that all 3 tubes have the same center line above the table. Good shimming material. Just about anything. Pieces of plastic. This one is 2 millimeters thick. This one is 0.4 millimeters thick. This one's 0.3 millimeters thick. This one is 1 millimeter thick. 20-pound bond paper is 1/10 of a millimeter thick. There are quite a few different things that you can use for shimming material. You could even use dollar bills if you want. The first thing we need to do to these two frame sets is we need to take out the center material in here. For lack of a better term, I'll probably just refer to it as reaming. It's actually not a reaming process, it'll be a filing process. But just from force of habit, I'll probably call it reaming. We need to get a nice fit on these lugs. This is much too tight for a lug. It pushes on too hard. We need to get a nice fit with all the tubes on all the lugs. They're all too tight. Need to get a nice fit on the steering column and the fork crown, bottom bracket shell, seat lug, and 2 head lugs. So let's go over to the vise and see what we can do about getting those reamed out. Let's start with the lower head lug here. There's a little bit of a lip around here that's keeping the head tube from going through, and the head tube doesn't slide through very easily. You'll find that it's necessary to ream these out just about no matter what brand they are. I use an 8-inch Nicholson half-round file. I prefer to use Nicholson files. They're a lot better than the files that are coming in from China, Taiwan. Definitely use an American or a Swiss file. Far superior quality. Anyway, just take the piece like this and file out that inside surface. Take out all those little burrs and try not to distort the shape of the lug itself. These are really quite nice. That one's all set to go. Took just about nothing. The lug should drop under its own weight, just like that. That one's a perfect fit. If we take the other head lug, this particular one has a little bit of a bend on this point. So I'm just going to grab a pair of pliers for a second, and I'm just going to straighten out that point. If I straighten it out, it'll still be there when I get done filing. If I don't straighten that point, we'll lose it during the filing process. Again, if the lugs are nicely shaped or nicely cast, you won't have to do too much of this. This one's still a little bit tight. It's going to take a little more work. Some of our lugs might need a little bit of helping along. I'm going to use a die grinder with a sanding drum on it. The die grinder is rated at 22,000 RPM, and the sanding drum is not rated near that speed. So you'll notice when I use this, I'm not going to take it up to full speed. I'll probably keep it down around quarter speed. And we're going to stick it inside the lug, and we're going to go around like that. And we're going to clean that inside diameter out of there until it'll drop onto the tube. We want to make sure that we don't rock it like this, so we wallow out the opening. So here we go. Okay, those of you that are used to listening to machinery can tell that I did not take that thing anywhere close to its full speed. If you want to use a die grinder at full speed, you have to use properly rated stones. These stones over here are rated at 25,000, so they'll work fine in that die grinder at full speed. This time we're going to help the seat lug along a little bit. This time we're going to use a properly rated stone for the die grinder, so this can be run at full speed. We're going to go in here and we're going to clean this out, being careful not to rock too much when we do it. notice on my vise that I'm using a set of soft jaws. These are just made out of aluminum plate. You can also use brass or copper, and you just put them in the vise, bend them down and form them with a hammer. That's so that the sharp teeth on the faces of the vise will not ruin anything that you clamp in there, particularly this bottom bracket shell, which I'm going to clamp in there. I wouldn't want to clamp down on those faces like that with those vise teeth. This way the soft jaws will hold them plenty tightly, but they won't scar the surfaces there. We're going to take out the inside diameter of the seat tube socket here. And let's take a look, see how it fits. It shouldn't take very much. There we are. Need just a little bit of slop there. We need that extra room for the silver to go into. And finally we have our fork crown here. This particular fork crown, this Henry James fork crown, fits quite nicely. You want to have a little bit of slop there. You might be able to hear that little wobble there if I hold it close to the mic. That slop is important because that's where the silver has to go down inside to. Anyway, that's already a nice fit. If you didn't have a good fit on this fork crown, what you'd want to do is put something like this carbide burr on your die grinder and go down inside here and clean that out with that. One thing about this particular fork crown is that it has a blind hole. In other words, the steering column bottoms out, and that's actually fork crown down there at the bottom rather than steering column poking through. And because of that, you'd want a nice square surface to go down in and bottom out like that. After these holes have all been reamed out so that they fit onto the various tubes, if you run your fingers around here, you'll feel some really jagged edges, some wire edges that have to be removed. If you don't remove those around there, the silver will gather up in those and they'll be quite visible after the silver cools. So what I usually use is a jeweler's file. Again, if you can get Swiss made ones, they're much better. The Chinese ones will wear out pretty fast, but of course the Chinese ones are so incredibly cheap that maybe it's worthwhile in this case. Anyway, we're going to just take these jeweler's files and go around the edges of all of these openings like this and remove that little wire edge that the die grinder left. The filing with the 8-inch Nicholson half round also leaves these little jagged edges. So you'll want to go around all these areas that you've altered until you don't feel that wire edge. Run it inside there, basically just like honing a knife, until it feels nice and smooth, nice and sharp. We're going to have to go around the edges of the lugs, all around those areas. Do not go around the area where the press fit for the bearing is. Do not do anything to the area where the bearing cups screw in place. We'll also have to do some things like we'll have to clean off the numbers here. This says 73 degrees. I'm sure your customer doesn't want 73 degrees written on his or her bike. There are also some forming mold marks here, some little lines. We'll want to remove those. Also on some of these, the gate where the molten metal went in to form the lug is rather obvious. In this case, on the back side of this ear for the binder bolt on the seat lug, this gate is kind of lumpy looking, so you want to take that and round it off nice and smooth, make it look nice before we do our brazing. This lug right here, this is where the gate is, right out here at the very end, and we don't have to worry about that gate because our cutter tool will remove that gate later on. And I believe the gate for the bottom bracket shell was on the ends where it's already been faced by the manufacturer, so you don't have to worry about the gate there. But here again, go after all of the imperfections and blemishes that might make the bike look not quite as nice when it's finished. To help us do this, I've made some things that I call lug mandrels, and the lug mandrels basically work just like a handlebar stem. Maybe I can take one partly apart. You can see a plug up inside there, and you can see the end of my mandrel is split right there, and also shaped. It's mitered, so that when it does go up inside a lug like this, we just stick it right in here and tighten that down, and that'll hold our lug quite tightly for us while we do all of our work all around it. Another tool that I have is actually a combination of a couple tools. If you look at the base of this vise, it's called a Wilton vise. I'm not sure if they're still made, but you can pick them up at used tool companies. This one I picked up for $5. And you can see that it has a ball and socket type joint, which will allow us to position this lug mandrel with a lug on the end of it in any position we want to work in and lock it in place. As I said, it's a combination of two tools. The top half, this is kind of exorbitant, but the top half is a Starrett number 567 V-block. Regrettably, that's about a $140 V-block, which is kind of an expensive V-block to make into a vise, but it certainly works nicely. It holds anything I want to hold that's round, and it allows me, to move this in any position. A couple other files I like to use. This one's a 6-inch Nicholson half round, and this one is a 4-inch half round. I got it out of a set. I know Nicholson makes one too, but this is some off-brand. I use these for doing things like taking the numbers off the lugs and taking the seams off. I use the little jeweler's file for taking those wire edges, the burrs, off the edges of the lugs. Anyway, let's start working on cleaning these lugs up. Notice that I move my hands as I'm working. I don't just file flat, flat, flat. I file around in a circle so that I don't put too many facets onto my work. Again, there's that handle. You see how that works. Put this lug in any position I want it. Do a little bit of left-hand filing here so you can see it. Taking off this little burr right on top of the lug. Use our little jewelry file here. And we're just going to go over the whole lug, all three lugs, bottom bracket shell and fork crown, in the same manner. After you've gone over the lugs and the bottom bracket shell and the fork crown with the jeweler's file, you'll probably want to use some emery cloth strip. This is made by 3M, and it comes in a variety of different grits. I'm going to be using mostly 120 grit on these lugs right now. However, the stainless steel lugs will end up being polished down to a fine finish, and with that we'll go all the way up to 500 grit, and then afterwards we'll use green jeweler's rouge to smooth it out just like chrome. So you end up tearing piece off. I usually tear a piece off about 18-20 inches long, and right in those areas where I filed those blemishes away, I'm going to go over them by sliding that emery cloth under my thumb. And if you control it just right, you can use your thumb to shape it as you're doing the sanding. Just right under the thumb, just like that. And this will give you a nice final finish, ready for the silver brazing. Right now I'm only doing the seat tube socket, and the reason for that is after we attach the seat tube socket, then we've got a handle to hold onto this thing, and that's when we'll ream the down tube socket. Chainstay sockets will be reamed much later. Just go around all these edges. If you have not very thick skin, you might want to put a band-aid, a fabric band-aid on your thumb right there, because guaranteed the newcomers will sand right through their skin and they'll leave a little streak of blood on their work. Okay, if we come over here, here's one of our lugs. This lug has been filed down. Now we'll take the sandpaper and go over the whole surface. Don't forget the head lug. The two head lugs are stainless and will be taken right down to a jeweler's rouge. So this 120 is only the first step toward getting this done. You have to sort of learn how to pick your thumb up at just the right time, because that metal gets really hot underneath there, and if you leave your thumb down after the sandpaper is pulled out from under it, you burn your thumb every single time. So we're going to spend probably 15 to 20 minutes per fitting to completely go over them and sand them smooth with the emery cloth. With the oversized tube set, we have a top tube and a seat tube that are the same diameter. Of course, the top tube is double butted and the seat tube is single butted. Now that presents a problem. We look at these two tubes, they look identical to each other. How do we tell which is the top tube, which is the seat tube? Probably the easiest way to tell is to take the seat tube, the seat post is supposed to go in here, slide it in there. It doesn't go in there. Slide it in here. It doesn't go in here. Doesn't go in here. So it doesn't go in either end of those. Doesn't go there. It doesn't. That's it right there. That's the top of your seat tube. Another way to check this out is you can take what's called a tubing micrometer, and other than regular micrometers have a flat face right there and a flat anvil. This one right here has ball-shaped matching pieces there, and so that is made to go inside like this. There you go. You take a reading on that end, turn it over, take a reading on that end. And the tube that has different readings at each end is your seat tube. The tube that has the same reading at each end is your top tube. Now on the other tube set, the down tube and the seat tube are the same size. You do the same thing on that to determine which one is the seat tube. And it's very important to know which one is the seat tube and which one is the top tube. and which one is the top end of the seat tube. And I'm going to take a piece of blue masking tape and I'm going to put it around the top of the seat tube so it doesn't get mixed up anymore. Then we need to take the down tube and do the same thing. Take the lower head lug, slide it up so just enough pokes through. Take that carbide scribe. You're best off to use carbide scribe. Other scribes will not do quite as good a job of marking. And there we go. We've got a good mark all the way around. Then we'll go over to the grinding wheel and I'll show you how to rough it in. You'll definitely want to use ear protection and safety glasses for this next step. If you take a look at this grinding wheel right now, you can see that I've taken a star wheel dresser, which is right here, and I've actually dressed the outside of that grinding wheel so it's rounded. Also, this grinding wheel obviously does not meet OSHA requirements because I've taken off all the guards. I find it really difficult to build a frame with all the guards in place. Anyway, put your hearing protection on, safety glasses on, and we're going to use this grinding wheel, this specially shaped grinding wheel, to shape that miter. The next tool you're going to use is a little protractor like this. These are a cheap little tool. You can usually get these from someone like KBC Tools, or oh, there are a whole bunch of these places that send things out. Enco sells these, and when they come, they're square. I usually trim them round on the belt sander so they're a little easier to read. But this little screw right here loosens up, and you can turn this to any angle you want. Now I'm going to go to the drawing and I'm going to set this for the lower head lug angle. I'm going to set the, see, this is exactly 60 degrees. Very common angle on a road racing bike, 60 degrees for that bottom head lug. Smaller bikes will probably tend to be down around 57. Bigger bikes, maybe a 27-inch frame, you know, for a basketball player, will be up around 62 degrees. Something like a Terry bike, that bottom head joint is going to be probably down around 55, or excuse me, 65. Anyway, we're going to use this tool to take our angle off of here, and we will also use the same tool to take our angle off of the top head lug. So let's go over and start filing that head lug. As I promised you earlier in the video, I'm going to do as much handwork as I possibly can on this frame. We've got 3 tubes here that are all roughed in on one end. There's our down tube, there's our seat tube, and there's our top tube. However, they're nowhere close to what they need to be, and what we need to do is, with a hand file, take them down to where they're supposed to be. We've already taken the angle off of the drawing for the bottom head lug. So we'll clamp this in park stand. Make sure to have your park stand so it's not too terribly tight, because you can squish a tube with a park stand. And I like to put my tube in so that my miter is roughly horizontal to the ground. And you need 3 tools to check your miter. Number 1, you need that little protractor, that little cheap $12 protractor, because you're going to use that to check the angle. Now this is fairly close. Then you're going to need a little machinist square, because you're going to use that to run across the peaks of the miter. Make sure both peaks are the same height. And then you're going to use the head tube as a tool, and you're going to look underneath there and see if you can see light through the miter. And right now it doesn't look so good. Right now the peaks are too high. So I'm just going to take the file, again, Nicholson 8-inch half round. I'm going to take the file and just file those peaks down by quite a bit. Now, one thing that takes a lot of practice is the type of strokes that you do on this. I basically do 4 strokes. If I'm doing this quarter right here, I'm going to do a straight stroke right straight off the front of that miter. If I do off this quarter, I do a straight stroke off the quarter of that miter. If I do this back side right here, watch how I kick the tail or kick the file handle out of the way. Like that. I kick the file to the right there. That's the only way you can get that material out of there. And if I take it off of this quarter here, I kick the file handle to the left. See how I kick that file handle to the left? So all of your file strokes are going to be some variation of those 4. Tool number 1. We still have a gap there. Gap's getting smaller. A little word of advice, believe it or not, a more dull file here is going to probably work better for you. A sharp file is going to remove material too fast for you, and you're going to find that that contour is changing faster than you can keep track of it. So just a slightly, maybe not a dull file, but a more used file or a more seasoned file is going to help you out a little more. I'm going to shave that burr off with the file. I've got a burr around there because I'm going to use tool number 2 right here. Looks pretty good. This one's a little higher. So let's take a little off of this one. Take that burr off. And they're about the same height, pretty close. Now this one, yeah, this one's a little lower still. This one's still a little high. That's good. Check tool number 1 again. Looking fairly good. And we'll go to tool number 3. The angle is way off. We're off by probably 2 degrees. We need to take more out of the bottom here. Taking more out of this part. Pretty close, off by about 1 degree. I'm not filing up here at all right now. I'm filing all down here. Take the burr out, check the angle. Within 1/2 degree there. You have to learn how to move that file around to work on your contours. There we go again, our 4 basic filing strokes. Tool number 1. Well, I can't even see light through there right now. We'll take the burr off. To use tool number 2. Boy, that's really close. And tool number 3. the angle. The angle is off by maybe ½ a degree. Tool number 1. Can't see any light through there at all. Tool number 2. Again, it's almost perfect. Tool number 3. Looks good. That's our mitered joint. You might do yourself a favor to just run that file around the edges. Take off that burr so you don't have to practice the art of bloodless frame building. Actually, there is no such thing as bloodless frame building. And there's your joint. Bottom headlock joint completely finished. Now I'll go ahead and do the top headlock joint on my own, but let's take a look at how you can finish up the bottom bracket joint, which is a lot easier. Alright, now's the time to mark where our miters are going to be, which is pretty easy when you're doing a lug frame. Let's do the bottom bracket shell first. Notice I put the piece of blue tape around the top of the seat tube, so the bottom of the seat tube is going to fit into the bottom bracket shell, like so. Poke it through till it comes up. You can see on the inside how far in the seat tube is supposed to poke. So just poke it through till it comes up to the end of the area that you reamed earlier. And then take a carbide scribe, and we're just going to go all around with that carbide scribe, being careful to hold that seat tube and bottom bracket shell carefully in position with each other. Don't forget, this is hardened steel. This is that prestige, so the carbide scribe is not making quite as nice a mark as you'd like it to make. But just go all the way around. And when you pull it apart, you can see a pretty clear scribe line where we're going to have to clean material off. Your bottom bracket joint is one of the easier ones to miter. Actually, just grinding it off like that is good enough. You can braze it together and go on. However, building a custom frame, you're probably going to have people poking around, looking at it really closely, and when they see these bits and pieces of burr inside there, you're going to get criticized. So it'd probably be nice to take that extra little amount of time and clean up that joint so it looks good. However, if you want to go ahead and throw it in like that, go ahead, because the bottom bracket taps are going to go right through there and they'll cut off your excess for you. You're going to do your reaming later, and the reaming will cut off any excess in here. But let's just clean it up and make it look good for the would-be expert that's going to criticize and compliment your frame. First of all, just clean this up. Do it at an angle, because of course that down tube is going to intercept at that angle, so we want to file at that angle. Take your burr out of there. Let's tilt this horizontally. Again, we're going to be using those same types of file strokes as I showed you previously. Let's take the burr off. And let's take a look and see what it looks like in the bottom bracket shell. Looks really nice. I think I'm going to leave it just the way it is. It's top tube. your upper head lug. Stick that through like that, just like that. Take your scribe. We're just marking one end of each tube at this point. Do not attempt to mark both ends of any of the tubes. Just one end. It leaves a nice mark almost all the way around. And now we're going to rake the fork blades, and most tube sets are going to come with a set of straight fork blades. Some tube sets will come with pre-bent blades. I prefer the ones that are not raked when you get them because it allows you to put whatever rake you want to in them. And so right now we're going to go over to the raking mandrel. Alright, this is the raking mandrel right here. It has a 1 foot radius on the bend. Maybe looking at this one might give you a better idea what it looks like. Got a 1 foot radius on this arc right here, which is a continental bend. And this radius, the radius of the groove itself, is a 3/4 inch radius. You'll notice back here there's a piece of nylon to keep from scarring the end of the fork. Also down inside there's a stop that you can't go beyond, so each fork blade gets bent the same amount. Then there's also a stop right here. We're going to initially set that stop nice and high so we don't overbend, and then we'll work down to it. So I'm going to set that stop right up there near the top. And then I've got a cheater bar. I made this cheater bar out of an old British blade, kind of a flatter oval, an old British blade, and it slides right into the end of your continental blades and gives you about 6 inches of extra leverage. We're going to look right here, and we're going to make sure that that oval is in line with our bend. If it's not in line with the bend, you're going to have some fork swoop when you build this fork. Okay, it's in line. And let's tighten down these bolts down here and give it a very careful straight downward bend until you just touch that stop. Don't slam on it so hard that you put a dimple in here from the stop. It's not very much rake. That's probably about 25-30 millimeters of rake, but we're going to go back to the drawing and look at it. At this time though, we're going to stick the other blade in there right up against that stop. Make sure your oval's in line with your bend. Slide your cheater in. Very carefully take it straight down. And there we have two equally bent blades. Let's go back to the drawing. Alright, now as you see on our drawing, here's the center point for the front axle. And if we put our blade on the drawing, right down the two lines for the head tube, and we put our dropout in the end of the blade, you can see that we've got a good 2 centimeters still to go. So this is going to be a process of going back and forth to the blade bender until we get it just right. Obviously in the production line setup, they would already have the fork blade bender all set to go, and it would just take 10-15 seconds to rake each blade. But when you're building custom bikes one at a time, it's kind of a long process to rake a couple of blades. So we'll go back and forth between the two until we get them raked just right. Next, you're going to have to check the fork blades, see that they're both evenly bent the same amount. So we're going to put them on a smooth surface. This surface right here is a precision ground surface, and set this up on the high point of your arc so it just passes underneath. And that's it right there. Take your other blade and see if that one passes underneath. Okay, this blade isn't bent quite as much as that. I can see about 15 thousandths of an inch underneath there. What we're going to do is go back to the fork bending mandrel and just give it one more bounce in the fork bending mandrel, at the same setting. Don't change the stop, and we'll see if we can get them both to match. Okay, we're taking one final check here, just scraping on the bottom of that one, and this one, yep, just scraping on that one too. So we have two blades that are bent exactly the same amount. And here's our final check. The top of the fork blade is even between the head tube and straight on down, and then we have the dropout placed right on the crossing point for the on the drawing for the front hub, and they match up just right. Don't worry about any little discrepancies like this, because the jig will hold everything in place and take care of those discrepancies. Now we're going to check the fit of the fork blades into the fork crown. This is an Everest fork crown. This one is a nice wide one. We're going to use this one for the touring bike that we're making. However, the fit is really tight in here. Sometimes you can take your fork blades, stick them in the vise, and tweak them a little bit, and they'll fit into the fork crown a little better. I've already tried that, and this fork crown needs to be reamed out a little bit. So we're going to take it, put it in the vise, pointing up in the air, and I'm going to take, this is a carbide cutter, carbide burr on the die grinder, and we're going to go down inside very carefully. And you can, if you were close up and looking at this, you'd see that there were some black marks left from where we tried to slide the fork blade in. And I'm going to go for those black marks and try to open this up just a little bit. There we go. Nice fit, both sides. The blades will fit inside the crown now, but we also have to ream out in here. As I mentioned earlier, this is sometimes necessary. The steering column goes in here pretty tightly. You'd have to use a hammer to get it in all the way, and we want that steering column just to drop in. So we're going to use a little bit bigger die grinder this time. This is about I think about a 3/4 inch die grinder. Don't try to do that with a 1-inch die grinder if you're doing a 1-inch steering column, because all it'll do is get in there and vibrate and you won't even be able to turn it. Use something a little smaller like this one. After you get done reaming that out, the fork crown should just drop on quite easily like that, and the joint should wiggle just a little bit, and this one's just right. The next thing we're going to do is we're going to cut the slots for the dropouts, and what I like to do to cut the slots for the dropouts is I like to pre-assemble the two blades with the crown just like that, and then the crown becomes a jig to hold the blades. Slide the blades up through the vise. One thing that's important is that you have a vise that's wide enough to accommodate both blades at the same time. You can look down at the crown down there and get that crown turned so it's even with the slot in the vise. Then you know that when you cut your slots for the blades, they'll be in line with the center line of the crown. Don't squeeze too hard. You don't want to dimple these. However, they're pretty stiff down here. It's a small diameter. Then we'll cut a couple slots. We'll cut a couple slots down each one with a hacksaw. Between 6 and 8 millimeters deep. And about 3 millimeters apart. You'll be wanting to use a hacksaw with about 32 teeth per inch for this maneuver. If you use something with any less teeth per inch, it'll just snag on you. Then take a pair of needle nose pliers and bend out those little pieces. Hopefully when you get done, these grooves will not yet be as wide as the dropout. We'll try the dropouts in there. This is a double eye dropout by Shimano. This is what the customer has requested. And as you can see, they don't quite, one of them almost drops in, the other one's nowhere close, which is fine with me. Now, I like to use an 8-inch half round, or excuse me, 8-inch flat file, just a mill file. However, this is a pair that I've modified for frame building students, and this file, I've run the faces on the belt sander, so it won't cut anything this way, but it will cut this way. This one I've run the edges on the belt sander, so it'll cut this way, but not this way. So if you're not comfortable with using a file, if you use these type of files, you can go deep without going wide, or you can go wide without going deep, depending on which file you use. I'm just going to use this file because I'm pretty used to doing it. You'll notice I'm keeping the ends of the fork blades kind of down low to the vise. This makes a lot less chattering, a lot less screeching. That one looks good. A little bit loose on that one. One thing that's important when you're doing this, do not make your grooves dovetail shaped. Because the dropout is slightly tapered. Rather than making those grooves dovetail shaped, you probably want to make them just a little bit V-shaped. So I always make my slots just slightly V-shaped. Not very much. In fact, it probably wouldn't even show up on the camera if we were to show it on the screen. Okay, that one drops in nicely. This one drops in nicely. And we'll want to sight across here. They're both at about the same angle. Looks good. Now we're going to take these blades. We'll disassemble everything. And we'll turn the blade sideways. And I use this. This has about a 3/8 inch diameter. It's a Nicholson round file. Now I'm going to slide this thing across sideways. Make sure your file doesn't accidentally ride up over like that, because it'll take a point right off. We want to watch these 4 points. Make sure those 4 points disappear at about the same time. And there we go. We have nice little scallops in the ends. Kind of a little decorative effect. We'll fill that scallop with silver later. Right now we have some pretty serious burrs on here, and again we'll take some of this 3M emery cloth strip. About an 80 to a 100 is fine for removing this, and just shoe shine it off of there with the emery cloth strip. If it doesn't quite come off, then run it underneath your thumb and go all the way around the end of this thing. Get that all cleaned up. Some of these tubes come with a black treatment on them to keep them from rusting in storage. That black treatment is very hard to get silver solder or brass to stick to, so you want to make sure and remove that black treatment anyway. Run your round file down inside to take out the burr on the inside. Knock the dust off, and there you go. It's all set. Do the same thing to the other side. Alright, here's our head tube. It's very important that we have 2 air expansion holes for every tube in the bike. Some builders will skimp and they'll only drill 1 air expansion hole. I recommend 2. Not only for expanding gases to get in and out during brazing, but during the metal prep, if you have a second air expansion hole, it lets your metal prep solution get inside the frame and wash around inside, and you can easily get it back out again. So what we're going to do is we're going to take this tube, lay it on the drawing right where the head tube fits, and we'll just eyeball 1 mark for the down tube, center of the down tube, and we'll eyeball another mark for the center of the top tube. We're going to drill 2 holes right on those 2 marks. So let's go back over to the vise. Alright, drilling procedure is pretty easy. We're going to take a center punch and make a nice heavy center punch on each mark. And I'm just going to do a 1/4 inch drill. That's a hand tightened chuck. It doesn't hold the drill bit as tightly as a chuck with a key would. That's why it would spin every now and then. But there we go. There are 2 air expansion holes, 1 for the down tube, 1 for the top tube. Our next step is to cut the slots in the ends of the chain stays for the rear dropouts. And this particular set of chain stays is a round set, so we're going to have to put our own dimples in later. This is going to be exactly the same as doing the fork blades. You don't have to do the pair at the same time, because since they're round and since they're not raked to match each other, we can just do 1 at a time. So we'll put 1 in the vise, cut our slot, two slots about 8 millimeters deep, between 6 and 8. You want to end up at about 8 when you're finished. Break that piece out of the center. Hopefully you didn't cut them so wide that it drops in place already. I like to file up to it rather than go over. A lot of sideways pressure here, trying to open that up. Very little downward pressure. And I'm also making it into a V shape rather than a dovetail. There we go, that's it. Another thing you might find yourself having to do is just round this a little bit. Get that tab so it'll drop inside the chainstay. If you take a close look at a set of dropouts, you'll see that this tab is not very often too symmetrical. So just rounding it out with that file will get it to drop in a little better. I've got the two rear chainstays slotted for the rear dropouts, and what you want to do is you want to sight across there to make sure that both your dropouts are sitting at the same angle, and they're both looking really good right now. So what I do is I take these carefully on the underside at the big end. For the left dropout, I file one notch, and on the underside of the tab for the left dropout, file one notch, so that goes back together the same way it came apart. For the right dropout, on the underside, file two notches, and on the underside of the tab of the right dropout, file two notches. This way we know that when those things go back together, they go back together in exactly the same way that we wanted them to. Then we can take our 3/8 inch half round, or our 3/8 inch round file, and put that scallop in the top here. Alright, here they are. I've got them all sanded, and the scallops are in there. Nice pointed scallops. The sharper those 4 points are, the nicer they look. One thing that we have to do to the right chainstay is on the inside face, opposite the name, the inside face here, we need to cut that a little bit short for more chain relief. If you don't, you're going to have trouble getting clearance on that smaller sprocket. So what I'm going to do is carefully cut off about half of the scallop on the inside face. Not very much. I don't know if you can see that in the video. Right there, that's the amount that I cut off. And now I'm going to take my 8-inch half round, which is the file that I prefer for this, and I'm going to file a flat rather than a scallop. It's tricky to hold that file just flat enough, but you have to. You don't want a bunch of facets at this location. It'll look really ugly. Now I'm filing down just enough to make points. There we go. And then we can take a really small half-round file, or round file, excuse me, round file. This is about a 4-inch round file. Has about, 3/16 diameter. Pretty small one. And just clean that burr out of there. And I don't know if you can see that, but you can see that I've chopped one side off, and I still have 2 little fingers sticking up on the short side, and those 2 little fingers are going to grip that dropout to keep it from falling during brazing. So it's important to have the 2 little fingers on the short side, and here's our scallop side on the outer side. Here's our steering column. Steering columns can be kind of confusing to cut sometimes. If you're building a really big bike, don't cut anything off the bottom. You need all the strength you can down here at the bottom for a really big person. If you're building a really short bike, you may have to cut all of it off the bottom and get rid of the butting completely. If you're building kind of a medium-sized bike, you might want to cut just a little bit off the bottom and then put the extra threads you need at the top, which is what I'm going to do here. The butting down at the bottom, we've got a butt down here. The butt is usually about 2 inches long, and I don't want to cut all of it off, but if I leave all of it there, this is going to be a fairly short bike. If I leave all of it there, the handlebar stem won't be able to go down to the right height. So I'm going to cut about 1 inch off the bottom, and then I'll just build it as is, and then I'll put the threads I need at the top. While you're cutting through this one, you're best off to use a much coarser tooth. This is 14 teeth per inch on this blade. That 32 teeth per inch like I have on the other blade is not going to do a very good job. You'll wear yourself out. Try to hunt around for a 14 tooth per inch hacksaw blade for this particular job. Okay, if you want to square up the end of this, you can, particularly for fork crowns that have a shoulder inside there where the steering column bottoms against it. That way you won't use up too much silver filling that area up. However, if you're using a fork crown like this one happens to be a Chinelli where it just pokes all the way through, you don't have to bother squaring it up at this time. Later you'll want to go in there with your file and clean that up and make it smooth. We are now at the end of what I call the general prep, and so let's just recap quickly what we've done. First of all, we have a seat tube that has been mitered to fit into a bottom bracket shell, which we have cleaned up and reamed the seat tube hole. We have a head tube which has been drilled with 2 air expansion holes, and that fits into a reamed lug right there. And also we have a down tube that has been mitered to fit the back of that head tube. So there's our hockey stick. I always call that the hockey stick. Don't bother about those 2 other holes. I'm not using that end of the tube. We have 2 seat stays, which we have done nothing to. We have a fork crown, which has been reamed up here so the steering column easily fits into it, and the steering column has been cut to rough length. The bottom of the fork crown has been reamed out so that the fork blades fit, and the ends of the fork blades have been slotted and scalloped to accept the dropouts. We have a top tube. Only the front, where it meets the head tube, has been mitered. We have two chainstays, which are distinctly left and right chainstays. They've been slotted and scalloped. And the right-hand side has been cut back on the inside surface for sprocket clearance. We have a reamed and cleaned up top head lug, and we have a reamed and cleaned up seat lug. That's everything. That's the end of the general prep, and our next step is going to be to do some brazing. Well, this is not really meant to be a toilet bowl cleaner commercial, but this is the best stuff I found anywhere for cleaning the ends of tubes and the insides of lugs and fork crowns before brazing. This is put out by the Dial Corporation, and they have an 800 number here, 1-800-457-8739. I found that in some parts of the country they don't sell it. The active ingredient in here is hydrochloric acid. It's a mild solution of hydrochloric acid, and it's just the right amount to clean up tubing. Do not try to use swimming pool chemicals. The hydrochloric acid that you'll get from going to a swimming pool place is going to be much too strong. Try to find some of this toilet bowl cleaner. There are only 2 or 3 brands that have hydrochloric acid in them. Don't do this indoors. It's kind of hard on stainless steel sinks. It's really hard on concrete. Do not pour this stuff out over concrete. Even after you think you've cleaned it up, it continues to attack the concrete for several days, and it can literally turn the surface of your concrete into dust. Also, try to save this stuff after you're done working with it, because it'll last for quite a long time. We're just going to soak the ends of the tubes, the fork blades, and the chain stays. Actually, I don't even have to do the steering column, because the steering column is, I can sand the steering column. And then we're going to carefully brush with an old toothbrush. Don't use your favorite one out of the bathroom. I'm going to brush the insides here. You can leave this sitting on the metal for some time without worrying about it. As soon as you rinse it, you have to dry. And I usually dry this with a compressor. But as soon as you hit this with rinse water, you must dry immediately, within seconds. If you hit this with rinse water and you don't dry within seconds, you'll have a very thin dusting of rust forming after only 30 or 40 seconds. So after you scrub these can sit for several minutes. Nice for getting inside surfaces and irregular surfaces, particularly up inside these blades and stays. You can see how it's taking off. That black treatment on the outside just comes right off. Okay, that's all the cleanup is, and we'll go in, we'll do a rinse, and then we'll do a really fast dry. Here we are at the kitchen sink. It's probably okay to do your rinse in the kitchen sink. Just don't do your acid cleanup at the sink. We've got everything submerged totally in cool water. I would not recommend using hot water, because with the hot water it speeds up the corrosion process. With cool water, when you take them out of the water, you've got a few seconds to make it to the air gun to start cleaning them off. If you do this in hot water, they start rusting instantaneously. So make sure to rinse in cool water. Leave them submerged, because I'm going to take these chainstays first and go blow them dry in the shop, and I'm going to leave the rest of this submerged. Now I'm going to blow dry everything, just 1 or 2 items at a time. Here's our last piece. They're all cleaned up, rinsed off, dried off. And if you've done this correctly, you won't see any rust deposits on there, and the metal will be a nice grayish color. with no impurities on the surface.